So the topic for today's discussion is thermal conductivity. Let us consider a rectangular slab whose thickness is X and whose cross-sectional area is A. The temperature at its this surface is T1 and the temperature at the other end of this rectangular parallelepiped is T2. Q amount of heat is flowing through it perpendicular to the surface. Now from experimental it is observed that this amount of heat Q is proportional to the area A. Q is also proportional to the temperature difference T1 minus T2. It is proportional to the time of flow and inversely proportional to the thickness X, which means that if we increase the temperature difference between the two slabs, then the amount of heat flow will increase. If you increase the surface area, amount of heat will increase, and if you increase the time of flow of heat, then also the amount of heat will increase. But if you increase the thickness, then the amount of heat will be less, then the amount of heat flow will be less. So from this we can write Q is equal to a constant K into A into T1 minus T2 into T divided by X. Now we can also write it in calculus form dq by dt. T we have taken here q by t, dq by dt. It is the rate of flow and it is equal to minus ka dt dx. Now why there is a minus sign? First you need to know that dt dx, this dt dx is known as the temperature gradient. This dt dx is known as the temperature gradient, and this k is the thermal conductivity of the material, and it is dependent on the material only. It is independent of the dimensions of the material, dimensions of the rectangular slab or any object, but it is only dependent on the material of the slab. Now temperature gradient dt by dx or t1 minus t2 by x, the negative sign in the calculus expression comes because the temperature gradient is negative in the direction of flow of heat. Supposing it is flowing from this part to that part, the temperature at this surface T1 is greater than the temperature at the other end T2. So as we go from this end to that end, the temperature gradually decreases and X gradually increases, means the thickness gradually increases. So as T decreases as X increases. So the temperature gradient is negative with the direction of flow of heat. That's why this negative sign comes into the picture. Now from this expression we can write k is equal to q into x divided by a into t1 minus t2. Now if a is equal to 1, x is equal to 1, small t is equal to 1 and t1 minus t2 is equal to 1, then we can write k is equal to q. From this we come to the definition, quantitative or numerical definition of thermal conductivity, and it says that the thermal conductivity of a material of a substance is numerically equal to the quantity of heat that conducts in 1 second normally through a slab of unit length and unit area, the difference of temperature between its end faces being 1 degree. Means if the temperature difference between this two ends is 1 degree and the cross sectional area is 1 unit and the thickness of the slab is 1 unit, and the heat flows through 1 second or one unit time, then we can write that k is equal to q, which means the amount of heat that will flow through this object will be equal to the thermal conductivity of that body.